Okay, so this is a video on the second paper for the sample math methods paper, right? Um, I have to make this video pretty short, so we'll be going through the questions pretty quickly. I've not attempted the questions, only the multiple choice, because in the stream that ended prematurely, um, I went through the multiple choice of paper two, and then I realized it ended. So I have completed the multiple choice. Okay, so we'll be going straight into it. Question one, determine the asymptote of the graph of the function f of x equals log base 3 of x plus 5. Okay, the asymptote occurs when whatever's inside the brackets equals 0. So x plus 5, right, equals 0. Well, it cannot equal 0. So then we just subtract 5 to the other side, so we get x equals negative 5, which is A. Question two. The population of bacteria after T hours is given by Pt equals 5,000 e to the 0.18 t. Okay. The rate of increase, so we need to find the derivative of the population. The nearest unit is 15 at 15 minutes is what? Okay, 15 minutes, that's a quarter of an hour. So we need to pay attention to units here as well. Okay. So if we plot that, we can plot the graph, right? So 5,000 times e to the 0.18 t, which in this case we're just putting as x. Now we're finding the rate of change at 15 minutes. 15 minutes as a quarter of an hour, so we sub in a quarter because t is in hours. Then to find the slope at that point, we can actually use function slope. So we get 941, and we've rounded that to the nearest integer, the nearest unit. So that's going to be D, as you can see, which it is. Using the trapezoidal rule with 4 sections, the approximate area under the curve y equals x squared plus 5 between x equals 0 to 2 is what? Okay, here I've actually done the working out. So this is the original function. Trapezoidal rule is the area equals the width over 2. So in this case, the width is 1 over 2 because there's 4 intervals, but it's from 0 to 2. Just get the difference, which is 2, and then divide it by the intervals, which is 4, so 1 over 2. And then it becomes 1 over 4 because you're dividing the width by 2. Then you sub in the values for x at the intervals. So the first interval and the last interval are just 0 and 2. When you sub in 0, it's just 5. Sub in 2, it's 4 plus 5, so that then it becomes 9. I added them together for giving 14. You double everything else. So since there's 4 intervals, there's actually 3 in between the first and the last. That's half, 1, and 3 over 2 respectively for the x values. So we sub those in. Okay, so half squared is just 1 over 4, and then plus 5, which is 20 over 4, you get 21 over 4, and then plus 6, because 1 squared is just 1, so 1 plus 5 is 6, and then 3 over 2, all squared, is 9 over 4, and then you're adding 20 over 4, so it's 29 over 4. 21 plus 29 over 4. Well, first, I distributed 2, so then it made the denominators a half, and then I doubled 6, yeah? Then I added these two, because they're easier to add together, so that gives 26. This is we're just adding the top numbers, so 21 plus 29 is 50. 50 over 2 is 25. And then this becomes 51 over 4. 51 over 4 is 13 minus 1 quarter, which is just 12.75, which is B. Question 4. The area of the region enclosed by the graphs. So this is tech active, just use technology. Okay, so first we graph x times square root of x plus 1, and then the second graph is 2x. Then we plot it. Okay, so the area enclosed between the functions. So what we're trying to do is we're going to use on HP prime, first find the intersection points, so the bounds. They intersect at 0, which makes sense. There's another intersection point at 3, so 0 to 3. What's above it? In this case, it's the purple function. I'm not sure if you can see that clearly. I'll change it to yellow. So in this case, it's the yellow function that's above it in that region. So we switch it to we use our keypad and we switch it to the yellow function. Then we go signed area from 0. We press enter again. And then above that function, 2, 3. We get our area as 1.26666 recurring, which is rounded to 1.267, so A. Okay, I did not want to see a comment about that number that I just said. Okay. No. Okay, question 5. Two particles move along the x-axis. For 0 to t is between 0 and 5. Their respective position functions are given by x1 equals sine of 2t, and x2 is e to the negative 2t. For how many values of t do the particles have the same position? A lot of these questions, I noticed when I was doing them, a lot of these questions just require using the graphics calculator and just graphing them. Like, that's all you need to do. So again, we just graph them. Yep, and we press plot. Okay. Then we need to remember the domain. So it's from 0 to 5. So there's 1 intersection, 2 intersections, 3 intersections, 4 intersections. But this is x equals 5, so it's just 4. We don't include this one over here. So there's 4, which is A. Okay. Side lengths of a triangle, again. Graphics calculator. I cannot reiterate this enough. Okay. You know, you don't need to provide working, so why bother? Okay. Look, see, it's already here. I've already done it for you. Okay. So the ratio between the sides are just 2, 3, 4. You just enter 2, 3, 4. Okay, that's it. Then you press solve. Boom. I've already solved it, so I've already pressed solve. The smallest angle. It wants the smallest angle. 104 definitely is not the smallest angle. 46? No. It's 28.96. So let's see. Okay. The graph of y equals x cubed minus 6x squared is concave downwards. When is it concave downwards? Okay, well, guess what? You could use second derivative. You could work out the second derivative. Or, instead, you could graph it. Yeah, that's exactly right. Okay? You can graph it, plot, when is it concave downwards? Let's see. So in this region, it's concave upwards. Yeah, it's like this way. This is concave downwards, right? That's what we want to see. So it's here. Okay, the point of inflection is somewhere going to be half of it. Now, based on the values, we can actually see, based on the answers, we don't need to find the point of inflection exactly. The answers give it to us. So the point of inflection is going to be somewhere positive, right? Somewhere around 2. And guess what? There's only one answer with 2. X is less than 2, right? We want it to be less than 2, then it's concave down, right? It's on the left side, that's concave down, so it's C. Obviously, you can use proper mathematical reasoning, like, second derivative, and then show that it's negative, in that region, but yeah. It's multiple choice, so yeah, there's no real point. Okay, so we have a velocity function. A particle travels along a straight line with a velocity of vt. So this is a velocity function. Again, it's asking for the acceleration at 2 seconds. We can just graph the function, use the slope function on the calculator. So I'm not talking about like the rate of change, the derivative of the velocity. I'm talking about but I'm not talking about the derivative function of the velocity. I'm talking about the function on the calculator. Okay, I'll show you what I mean. So the velocity function is 3e to the negative t over 2. And this is multiplied with sine of 2t. Then we plot. Okay, we want the acceleration at t equals 2. So we sub in 2. We press 2 and then we press enter. Okay? Then that's not what we want. That's the velocity at 2. So we go function. This is exactly what I meant. Function on the calculator. I didn't mean the derivative function. So here we press slope like we did in the previous questions. We get negative 1.03. Rounded to 2 decimal places since the answers are provided in 2 decimal places. And that is A. Okay. The birth of babies is normally distributed with a mean of 3,500 grams and a standard deviation of 500 grams. Okay, we're given mean, standard deviation, and then we're given a probability. So immediately we can go to our home button, toolbox, probability, suppress 5, 7, cumulative, normal. It says it's normally distributed. Okay, if you forget what this function does, you press the help button, it provides an explanation. Okay, it's the lower tail probability. So the probability that the birth mass of the baby is less than. So that's the lower tail probability. So we can just enter that value right in. So in this case, K is 3,200. Well, in this case, it's actually X. Never mind. K, I think, is the value they use in the binomial CDF function. Okay, so we just put the mean first, then we put comma, standard deviation is 500, then we put comma, then we put the X value, 3,200. Gives us the lower tail probability, 0.27, which is D. It's D. A survey found that 142 people out of 200 people aged 30. Okay, we don't care. Okay, we just need to know that that's our population proportion. Or no, that's the survey population proportion. Survey, that's the sample proportion. Okay, and then we need to find out a 95% confidence interval. Okay, so here what we do is you can use inference. Inference is very, very useful thing for this. We're trying to find out the confidence interval of the population proportion. So we use pi. We go to num, right? Numerator. Or I don't know what it actually stands for. See, I've already done it. X is the number of success, I suppose, in the proportion thing, or not the amount of people in the sample that have the thing. 200 obviously is just sample size, yeah? You can see it. And then 0.95 is the confidence interval, since it's 95%, calculate. And then you get a range from 0.65 to 0.77. Which in this case is C. Okay, 10 out of 10, that's good. Good start, but now we have to actually do the questions live. We were doing the questions live anyway, but okay. Now, in this case, exam insights, be gone for a bit, Okay, we have something, it's a logarithmic scale, like obviously this is, you can read it in an exam, but it's not extremely mandatory. So we just need to know that P represents this scale, and then this part is kind of irrelevant. We don't need to necessarily know. Potential impacts with positive Palermo scale values will generally indicate situations that merit some level of concern. For the Neo asteroid Apophis, P is given by this function, so that's all we need to work with. Okay, that's the important part. P represents the impact, Pi represents the impact probability. Determine P for a value of this 1 in 100,000, so it's going to be Pi is 1 over 100,000. Yeah. Okay, so we just said that in. It's 1 mark, so you can just use your technology to work it out. So log base 10, so we just do log 1 over 100,000, and then we divide this by 8.71 times 10 to the negative 6, which gives us an answer of, for P, of 5.9982 times 10 to the negative 2. John believes that increasing the p-value by 2 will make the chance of impact 1,000 times more likely. Increasing by 2, I think that means adding, because if it was doubling, they would just say double, you know? Okay, let's think about it. P plus 2 equals log base 10 of pi. Yeah. And you change it to exponential form, so 10, which is the base, is to the power of p plus 2, and it equals pi over 8.71 times 10 to the negative 6. Okay. Then, pi we just multiply on both sides, yeah. So isolate pi. And then what we do is we sub in this value. Okay. 8.71 times 10 to the negative 6 times 10 to the, this is the p-value, so I'm just going to sub in that expression here. Yep. And then we add 2 to this. Okay. So we get an answer of, I'm assuming that's from rounding error. 29, like, okay, I think that's rounding error. 1 times 10 to the negative 3, I believe. Yeah, 1 over 1,000. It's just same thing, right? Same thing. Okay. So that means okay, original pi equals, what's that? I'm pretty sure it's 1 times 10 to the negative 5. Yeah, it is. The difference between that means it's only 100 times more likely. Therefore, not reasonable, so unreasonable, as only 100 Okay, let's check the marking scheme. Okay, you have 0.06, which is essentially the same thing. So one more, one a bit more precision from my answer, but yeah, it's acceptable. Okay, establishes logarithmic equation. I mean, I basically did that, and then I got this, which is in scientific notation, and then I basically said that 100 times more likely. I'll give myself full marks for that. Okay. In this case, I've stated the logarithmic equation. I just didn't sub in the value. And then I subbed it in there and I got the correct answer for P of I. And then I've evaluated the reasonableness. Okay. We have to pick up the pace a little bit. Yep. Type O negative blood universal donors. Okay. Great. Yeah. Type O negative blood universal donors 9%, so 9 over 100 is P. Yeah. On a random given day, random group of 45. Okay. Identify why this context is suitable for modeling as a binomial distribution. What do we know about binomials? There's success or failure. In this case, it's either you have type O negative blood or you don't. So that's why it's suitable. That's one of the reasons. Many other reasons you could provide, but that's my reason. People in the random group either have habit, success, and failure, respectively. Right? Determine the mean and standard deviation of the number of people who are universal donors. Okay, the mean for a binomial, a random discrete variable, is calculated as red pen to get a different color. NP, right? Number of trials, 45. Well, not number of trials, number of selections, I suppose. And then 9 over 100. Okay, so how does this work? Cancel 5 out, so it goes 9, 20. So it's 81 over 20. Let's just verify that. 45 times 9 over 100. Okay, yeah, it is. Equals 4.05. The universal donors, because they have O negative, right? 9% had this blood type, and then 45 people volunteered. So out of the random group, it was probably that amount. Okay, something to consider. We can always use a formula sheet. We can go to statistics in particular. Yeah, those are the formulas we need to be considering. Binomial distribution. Okay, so we've calculated the mean. We need to calculate the standard deviation. We need to recognize the standard deviation as the square root of variance. So it equals the square root of np1 minus p, right? That's just from the formula seen right here. np 1 minus p. So that's the variance. And then we square root it because that's actually not on the formula sheet, but it is something to recognize. Variance, the square variance is the standard deviation. Then you just sub it in. So we know MP, we just determined that to be 4.05, and then we get 1 minus P, which is 1 minus 9 over 100. Just in case, like, this is wrong, I wouldn't recommend doing this. I'd just recommend inputting the values. Okay. So we get this. That's our standard deviation. 1.92 to 2 decimal places. Okay. Determine the probability that no more than 3. So probability that x is less than or equal to 3. Because it can't be more than. It can be 3, but it can't be more than it. Okay. This is good. Because that's the lower tail probability. We can use binomial CDF. PK. N is 45. P is 9 over 100. K, in this case, is 3. It includes 3. That's something to consider. So we go here, probability, cumulative, binomial. So 575, that's the shortcut. 45, comma, 9 over 100, comma, 3. Lower tail probability, so we don't need to do anything other than just input the values. No need to get the complement. So 0.41, 2 decimal places. Okay, let's see. Two possible outcomes. I'd say that's basically what I wrote. Success and failure, two possible outcomes. Yeah, i.e. donor is a universal donor or donor is not. Yeah, that's basically, yeah, what I said. The mean is 45 times 0.09, which is 4.05. Yep, I calculated the mean. Standard deviation is 1.92, as mentioned before. Okay. Binomial. Yep. We just need to recognize this appropriate mathematical expression or representation, which is basically the same as this. We get 0.41, 2 marks, 4 marks for that. Okay, we're just deriving, so I don't think we need our calculator for this one. So what we're going to do is we're just going to do it by hand. Okay, so here, the derivative of this, we're just deriving that. Okay, so what do we have to do here? Well, let's think about it. Let's convert it to a different form, a more advantageous form. Okay, this is a reciprocal, right? This is being divided, so you can raise it to the power of 1, -1, and put it as a numerator. Okay, we keep everything in the brackets the same, so it's negative. So it's just raised to the negative. Okay, what else do we do? We need to account for the square root. When we express the square root as an exponent, it's raised to the negative a half in this case. So the half comes from the square root, negative comes from it being the reciprocal. Now we can integrate this. I mean, derive this. Okay. What happens? Get the derivative of the brackets. So when we derive 3t squared, we get 6t. Okay, this is multiplied by the derivative of this entire thing. So pretend the brackets is just one term. How do we derive that? We get the coefficient, we get the power as the coefficient, so negative a half, and then we just keep whatever's in the brackets because we treat it as just one variable. And then we minus 1 from the indices, so 3 over 2. This then becomes, when we simplify it, negative 3t, and then the brackets, so 16 plus 3t squared raised to the negative 3 over 2. Okay, now we're integrating. Okay, using the result from 13a, determine nt. So we need to demonstrate this. That's, yeah, or it's just quicker to use it. Okay, we should notice that both what's in the integral, right? What's in the integral has a t out the front. This has a t out the front. The brackets is the same, and then it's raised to the same power, which is negative 3 over 2. But the coefficients out the front is different. That's the only difference. Okay, what we can do is we need to make the coefficient negative 3. So what we can do is to make it the same, we actually factor out negative 600. Then to keep the coefficient, the overall coefficient being the same, we need to have negative 3 at the front. Negative 3 times negative 600 is just positive 1,800. So we haven't changed it. When we're integrating this, guess what? This is the derivative of what we just got. So we can just use this. We can just use mt. Okay. So this becomes negative 600 over square root of 16 plus 3t squared. Then we add plus c. Since it's an indefinite integral, we don't know what the vertical translation is. Okay. The derivative of n. So we need to get the value of the derivative of n at x equals 4. Okay. Well, when we derive this, it's just this. That's literally it. Yeah, that's it. So yeah. So derivative of the first derivative of nt, so n prime of t equals 1800 t 16 plus 3t squared to the negative 3 over 2. N prime 4 equals 1800 multiplied by 4, 16 plus 3, 4 squared, and then to the negative 3 over 2. Actually, since we have technology, let's just sub it into, let's just graph it. I think we were meant to do that. I think that was what we were meant to do. So 16 plus 3t squared raised to the negative 3 over 2. That's the derivative function. We go to t equals 4. We get a value of 14.0625. Graphics calculator. Let me just verify that. So this goes to 7,200. 16 plus. So this is 64 raised to the negative 3 over 2. Yep, it is the same value. Okay, so the model the NT models the total number of customers and served by staff after T hours during a 8-hour workday. T equals 0, no customers have been served. Okay. So 0 equals negative 600 sub n of 0 equals 0. Three 0 squared plus c. So then all it is this cancels out. 16 square root of 16 is 4. When you get 600 divided by 4, it's 150. So c equals 150. And t equals negative 600 square root of 16 plus 3 to the square 150. We can graph this. Negative 600 square root 16 plus 3x squared plus 150. We plot that. We get n equals 4. Okay, n of 4 equals 75. Graphics calculator. Sweet. There's our answer. Or our answers, plural. Statement using the chain rule. I think it's implied. I think implied, yeah, it allows implied working. It's implied through working. Negative 3t, and then that, negative 3, yeah, okay. It might not be, I might be wrong. So just be wary of that. Correctly determines indefinite integral. So this is 1 mark. Negative 600 brackets, yep. Correctly determines that. Apparently it's not the same. Not sure why. Not sure why. It says 14.063. Let me type it in exactly how they typed it. No, I'll get the value I got, so I'll accept that. Probably rounding error. Okay, we let it equal 0. Determine C, 150. Determines for n when it's 4. Yep. Box. Question 14. Solve for the two possible triangles using the information below. We could use our triangle solver, but it's by mark, so I'm not sure if it's allowed. What we will do is, yeah, let's draw a triangle. Just, yeah, A, B, C, A, B, C. Yeah, 27, 12, 25 degrees. Okay. So we can use our sine rule to work out the angle of C. Yeah, we could. Okay. Sine rule. Actually, using graphics calculator will help us in this question quite a lot. 7, 25 degrees. The angles are different. Okay. I don't know how to actually. I've actually never had to do that. Sine rule. We'll just use the sine rule. So it's 12 over sine of 25. So A over sine of A. And then C, which is the length of the side, over sine of C, which is the angle. Rearrange. So these swap. The fraction, the entire fraction, swaps with the denominator. Okay? Which is the same as 27 multiplied by sine of 25 degrees over 12. Now, what value is this? That's the question. 20 cancel. 27 sine of 25 degrees divided by 12. Okay, so let's think about it. 0.95, that's very close to 1, and sine is associated with y. So it's going to be like this. You're going to get two answers because sine's positive in quadrants 1 and 2. This angle is going to be like slightly less. This angle is going to be slightly more than 90 degrees. So that's where the two possible answers stem from. It's, you know, two solutions for C. Goodness me, what is that handwriting? Oh my goodness, let's take the time to appreciate this perfectly legible handwriting. That's, oh my goodness. If you can't tell, I was being sarcastic. Okay. Sine, inverse sine of this. We get the acute angle, right? The base angle solution. Inverse sine, 27 sine of 25 degrees over 12, 71.9693 degrees. Hence, other solution is 180 minus C. Right, we want the other obtuse solution. We go 180 minus C. And we go 108.03065 degrees. Okay, given that, we have to do it like this. There's no way, right? Like, seems a bit time consuming, doesn't it? Um, we have this, so we can use sine rule again. I mean, the sine rule is pretty convenient, but let's just use it in terms of A. So B equals 180 minus 25 degrees. So 180 degrees minus 25 degrees, that's from A, and then it's also minus C. So equals 155 degrees minus C. Okay. Sine rule again. We're going to divide it. We're going to divide our page into two. For C equals 71.96935 degrees. For C equals 108.65 degrees. Yep. Okay. I don't know if we can use triangle solver, but just in case, I'm not risking it. Okay, sine rule. Again, side length of A divided by sine of the angle A. And then B over sine of the angle B, which in this case is 150 degrees minus C. Oh, wait, this, we can just keep it like that, actually. Okay. Yeah, we can just keep it like that. I just realized that. B equals 12 sine of 150 C over sine of 25 degrees. So I multiplied this on both sides, so moved up. Therefore, then we just sub in the value. So 12 sine 155 minus the exact value. I'm just putting in the exact value divided by sine of 25. Yep, and then we get 28. Okay, then we change it. And instead, 155 minus brackets, because we're minusing the entire thing, since there's actually two terms in this case, we get 20. Let's cross-check with triangle solver. Yeah, that's exactly the difference. Okay, so here we have B being a side length of 28.18. B equals 20.76 over here. Therefore, A equals 25, B equals 28.18, C equals 71.97 degrees. Wait, no. C equals 27. A equals, oh my goodness, I'm writing the wrong ones. I was writing the angles. Okay. A equals 25 degrees. B equals, I can't really be bothered calculating the B angle. It's pretty simple though. We just do this. So 83.03 degrees. C equals 71.97 degrees. A equals 12, B equals 20.76, C equals 27, A equals 25 degrees. These are meant to be capitalized. B equals, no, I something up. 155 minus brackets 46.97 degrees. C equals 108.8. See how these are like mirrors, like the decimals? Yeah, something to note. Let me just cross-check with a triangle solver. Okay, so um, let's see. Angle, yep. Okay, the alternative solution. 20%, yep. Okay, so that is it, yep. So that should be correct. Let us see the marking scheme. Use convention for labeling triangles to construct a diagram. Yeah, I actually did that, surprisingly. Sine rule. Yep. C is 7.197 or yeah. Okay. Determine solutions for angles B. Okay, so you didn't need to actually do that. Oh my goodness. So you could have gone away with just oh well, that's one mark for both. Yep. And then associated lengths. Okay, so you probably could have just used triangle solver, but also at the beginning just shown demonstration of the sine rule. Okay. Question 15. Suppose the proportion that of Australians who support the removal of single-use plastic bags from supermarkets is 64%. So P equals 64 over 100. That's the population proportion. Using normal approximation, determine the probability that in a randomly selected sample of size 100, so n equals 100, more than 70%, so 7 over 10, probability x is more than 70% approved. What? Oh, okay, yeah. Probability that x is greater than 70 over 10. Yeah, and then we're finding out the probability. Okay, I don't know why it took me so long to actually read the question or understand the question. This is the upper tail probability, so we need to convert it to the lower tail probability. Since it's a normal approximation, it doesn't really matter that it's equal to. Okay, so in this case, wait, what? Normal distribution. I think it's a normal distribution. So this is normal, right? So in this case, it's not binomial. It's cumulative normal. Okay. The mean is this. That's something to consider. The standard deviation is the square root 1 minus normal CDF. Okay, I'm gonna go off the page, so I need to put the brackets here. 64 over 100 square root of the standard deviation of the variance. So formula sheet, sample proportions, we're dealing with that. Okay. So 64 over 100 brackets 1 minus 64 over 100 over 100, which is n. And then we're going to 7 over 10. Okay. 1 minus 64 over 100 divided by 100. And then we go over here, comma, 7 over 10. So that's the probability. Probability x is greater than 7 over 10 equals 0.164 decimal places. Okay. Determine the size of the sample required for the survey to achieve a margin of error. Well, margin of error, z square root p1 minus p over n. Yep. Margin of 4%. So 4 over 100 equals, in an approximate 95% confidence interval. Because we're trying to find out n. Let's rearrange. So I divide by z on both sides, then I'm going to square both sides. I'm subbing in 64 over 100 as p, and then I'm dividing this on both sides and then multiplying by this on both sides, so they swap. So that to get the normal, to get the z value, we go normal ICDF. This area is 95%. The area plus minus from the mean. To get the z value, we actually have to account for the part here to get to that. This on both sides is 2.5%, so it actually becomes 0.975. We have to sub in. Okay, so now we sub in everything. 1 minus 64 over 100. We divide by 4 over 100 times inverse normal, 0.975, which is z. So we get a value of 553. This doesn't seem right. This does not seem right. Either way, I think it's right. Okay. Pretty sure it is. Hmm. Yeah, I'm pretty sure it is, right? We'll just go with our gut. Therefore, n equals 553. It has to be rounded to the nearest integer, given the context, right? The number of Australians. You can't have part of a person. So we're not done yet. Identify the effect that halving the margin of error has on the sample size obtained. The margin error halving the margin of error to 2% would change the final equation. Final equation to n equals 64 over 100 brackets 2 over 100 64 over 101 minus 64 over 100, and then it's the e value divided by z all squared. In this case, it's halved. So this actually divides by 4, right? So thus the sample size required quadruples, because now you're dividing it by a smaller number So it's inversely proportional. It's inverse square. It has an inverse square proportionality. Due to inverse square proportionality. Comes. Let's actually calculate it, since we can just change it in the calculator. It's pretty quick. 2,212. Yep. Okay. Send the probability that in a randomly selected sample of 25, the sample proportion is equal to the population proportion. Okay. Um, the probability that x equals 64 over what? The probability that in a random probability that the sample proportion equals the population proportion. We know that n equals 25. I don't know if we need to involve the normal distribution and then that becomes the binomial. Um, not too sure about this. Um, let's think about it. Okay, 16 out of 25. 16 out of the people in this sample need to have selected the removal of single-use plastic bags. Okay. What's the probability of success? It's just 0. P equals 64 over 100. And we want R, which is 16. X is binomially distributed. It's a binomial distribution. 25, 64, and P equals 16 equals um cumulative binomial. You would just like you could use the formula sheet. But since we're only after 16, we have to put 16 twice. So I think that's actually the correct way to do it. Hopefully it is. Okay, let's mark it. So correctly determines the mean and the standard deviation, which, yeah, I've just written it. You know, I didn't put it in the calculator and then actually get the decimal, but that's basically what it is. Yeah, this is the correct thing. They rounded it to two decimal places. I rounded it to four. Okay. Establishes equation based on given information. Yeah. I just didn't sum the values. Reasonable size, so n is 553. Okay, four times as large, it quadruples. This is basically the same thing, yeah, but it's the rearranged equation. It determines the number of people that support the change. 16. 0.16. Look at that. Yeah, okay, so this is exactly what I was talking about. So you can use the formula that's shown in light gray, but I just use the cumulative density function because why not? Okay, I'm surprised I got that one. Okay, we're dealing with bearings. Okay. R picks up signals. A is stationary and on a bearing. Okay, A is stationary on a bearing of from R. So R is here. This is R. From R, A is on a bearing of 0.14. So that's A. This is 65. And then this is 41 degrees. So it's from R. It's measured. Ship A is on a bearing of 295. So this is 25 degrees. This must then be 65 degrees. And it's 53 kilometers away from 53. And that's B. Since this, it goes 90, 180, 270, and then we add 25. So that's where that comes from. Determine the time for ship B to travel to ship A. So we need to find this length. If ship B can travel at 30 kilometers per hour. Okay. First, we need to find out the length, and then we can find out the time. So A to B squared equals, let's pull up the formula. Cosine. Here you go. So A plus B, or AB. We know this length, 65 squared. We know B, which is 53 squared, minus 2 times 65 and 53 cosine of the angle C, which in this case is this. So 65 plus 41 is 106 degrees. Okay. So now you just have this. You square root everything. Minus. Obviously, you can use triangle solver. It's probably encouraged. Square root. But we can use triangle solver to double check our solution. That's what's good about this. 9106. We get a length of 94 point. Therefore, AB equals plus minus 94.5153 is 94.5153, right? It needs to be positive. Needs to be greater than 0. Okay. If it can travel 30 kilometers per hour, time equals the distance of AB over 30. Right? Kilometers per hour, so then it gives us how many hours. We don't need to actually change anything. So this divided by 30. 3.15 hours. Triangle solver. 65, 53, 106. 94 point, yeah, okay. Let's check our marking. Communicates information using correct mathematical representation. Yup. I'll give myself a tick there. Determines angle at R to be 65. Yup. Distance AB. Yup. Time is, yup. 4 marks. 17. One-day period. During one 30-day period, the rate at which pollution passes into a nearby lake is measured every 6 days, and the results are shown. Okay, it's a quadratic function. Determine the total amount of pollution entering the lake during this 30-day period. Okay. Alright, quadratic function y equals ax squared plus bx plus c. This turns into pt equals a t squared plus bt plus c. P of 0 equals a0 squared plus b0 plus c, which equals 7. Therefore, c equals 7. P of 6 equals a6 squared plus b6 plus 7. Right? 36a plus 6b plus 7 equals 8. Right, that's given. 36a plus 6b equals 1. P of 12 a 12 squared plus b 12 plus 7 equals 10. 144a plus 3. Okay, we have two equations. We can use simultaneous equations to solve. Okay, this becomes b 6b equals 1 minus 38 6a. So we divide that by 6, isolate b. We can use the linear solver in a graphics calculator actually. But, yeah, because it's 3 marks. So I'm assuming that's what they expect or what they allow. Linear solver. X is A, B is Y in this case. 36, 6, this equals 1. 144, 112 equals 3. 2 by 2. Okay. Therefore, A equals 1.38. How do I... Okay, I changed it into fractional form. 1 over 72. B equals 1 over 12. Okay. Therefore, PT equals 1 over 72 t squared plus 1 over 12 t squared plus 7. Okay, it's the rate of pollution per day, right? So we need to find the integral of that. Okay, so let's graph it. 1 over 72 x squared plus 1 over 12 x plus, this is not meant to be squared, plus 7. Plot it. Okay, we can see what it looks like. Let's just graph it. Something like that. Okay, get the signed area. Right, the area represents the total amount of pollution. So 0, from 0 to 30. Right, 30-day period. This area. Total pollution. Total pollution is area from t equals 0 to 30. Therefore, pollution equals 372.5. Graphics calculator. Roughly determines model. PT. No. I mean, we graphically represented it basically, and we wrote it in words. Same thing. The amount of drug in bloodstream. M represents milligrams, and T represents hours. Okay, okay. M of 2 hours equals 120, which equals A2 times 2 e negative 2b. 120 equals 2a e to the negative 2b. Then we divide, so it gives 60. That's a terrible bracket. A e negative 2b. This should have been divided to the other side, actually. Yeah. So now it's divided by a. Yep. ln of 60 over a equals negative 2b. Determine the exact values of the maximum amount or maximum. Okay, so that gives us a clue, actually. That's good. That's great. Negative 2b. Okay, given maximum, t equals 2. The derivative equals 0. It's a local max. When we derive this, it's the product rule. So uv, so the u prime v plus uv prime. So u prime is a, and we just write this, plus u, which is this, times derivative of the exponent times the just the same value. Okay. So then we sub in t equals 2. Okay, so it's negative b, so we have a negative out the front. E to the negative 2b. And this equals 0, and then we can factor out a e to the negative 2b. So 1 minus this and this, factor out, leaving us with negative 2b. 2b equals 0. 1 minus 2b equals 0. This can't be 0. It can't be. So therefore, b is a half. Yeah. Okay. We add 2b both sides, and then we divide by 2, giving us that. Okay. What do we do now? 60 equals a e to the negative 2b. Right, that's from this part. Because I rearranged for b, but we worked out b, so that's not good. This is from this when we simplified, dividing 2 on both sides. And then we just divide this, and then we also sub in b, which is a half, so it becomes negative 1. That's just e, 60e. Yeah, okay. So now we have that. Evaluate the reasonableness of your solution. Graph it. Graphing t. Let's graph it. So 60 e times t e to the negative half t, which is just x. Invalid exponent in number. Okay. Yeah, that's annoying. I don't know why I have to write it like that. Like it accepts that. Okay, at t equals 2, let's see. Yep, that's that's the maximum. That's the peak. Yep. Okay. Very sharp spike. Graph it. Um, 2, 120. Max at 2, 2. Therefore, reasonable solution. Okay. Let's see. Let's mark our response. Correctly determines derivative. Yeah. Determines B, a half. Yep. Determines A, 60E. Yep. Using graphing application. Yep. Maximum point. I'm away. Second last question. This is actually the question that my friends asked me to do. This specific question. It's a 5 mark question. We're going a bit over time here. Okay, normally distributed, mean and standard deviation. If x and y are two independent random normal variables such that, yep, they have their respective means and standard deviations, then when you subtract them, you get the difference of their means, and then add the what? And then when you add them, the means add, standard deviation adds again. Okay. Okay. Contestant A and contestant B have trained to navigate. Yep. They're independent. On any given day, the time is normally distributed. A, B, runtime, B, runtime. Okay, we just need to find out the area that overlaps when we subtract B from A. Yeah. When B is faster, we have a function. When we represent both of the graphs. 78, that's 80. When B is faster, it's this. Is it not that? Right? It's or B minus A. Okay, so I think you get that. So on average, it's going to be 2 minutes faster. So doesn't this just represent when it's faster? Well, no, it doesn't. The part that represents it being faster is when the probability of this is less than zero. Yeah, okay. We got it. We got that. Um, I'm a bit confused about this notation though. It's the square of the standard deviations, but you add them. What does that mean? Does that mean it's just the standard deviations added, and then, or is it variance added? Because this represents variance. Ooh, something to consider. Either way, it doesn't matter because you just square them and then you square root what you add. So, yeah. When B is faster, B minus A needs to be negative. It's smaller than A, right? Two, okay. 12, 12 squared plus 10 squared. 244. So the probability that B minus A is less than zero. That's literally it. Equals the cumulative distribution. So it's a normal distribution, normal CDF. You get the mean. Standard deviation is actually the square root of the variance. And then it's the lower tail probability to zero. That's it. Wait, there's no way. No, I don't trust this. If that's the correct answer, I don't know what to say. There's got to be a trick. There's got to be a trick to this. No, so therefore, prob this equals 0.5509. Therefore, what? I don't know. I I think that's correct, but I don't know why it's 5 marks. If I'm correct, let's say I'm ready to get humbled anytime right now. Recognizes it's the difference. Okay. Mean and standard deviation. Okay. What? Oh, this is the easiest, the freest 5 mark complex. I'm assuming it's complex unfamiliar. It's faster when this is negative. I basically said that. Lower limit, upper limit. Lower limit. What do you mean lower limit? What do you mean lower limit? What? Okay. I don't know. I mean, it's just this, right? That's essentially what they're saying. 55%. What? Okay, that was underwhelming to be honest. Um, yeah, apparently it's not that difficult. What? Okay. Wow. This one doesn't look that difficult either. It's also 5 marks. Farmer has a paddock with straight fences on two sides, fence A and B perpendicular to each other, as shown on the diagram. Okay, they're straight fences, which makes sense, yep. Bounded by a creek on the other side, yep, thank you for the labeling. It's 4 kilometers long. This is 4 kilometers long. Fence B is 4 kilometers. This can be modeled using. So D, this is D. The creek can be represented with this function, and that just represents the vertical, so the y value, which in this case is D. D is the perpendicular distance from fence A to the creek. Yeah, so it's perpendicular, yeah. And x is the distance in kilometers across fence A. Do we know the length of fence A? We know the length of fence A? Oh, we don't need to. Oh, no, we do, but that's one of them. That's one of the parts to this question. We're given this, and that's the perpendicular component of the creek, right? That's fence B. For for length of fence A, okay, so immediately we need to recognize that since they want to divide the paddock area in half, we need to find out the x value that separates the area from 0 to the x value and x to whatever the length of the fence A is. And those integrals need to be equivalent. We just need to find out that. The length of fence A sub D equals 4. 4 equals ln of 5x plus e minus 1. So 5 equals ln of 5x plus e. E to the 5 equals 5x plus e. E to the 5 minus e over 5 equals x. Yep, there we go. What value is that? I'm curious. Like 29 kilometers, which according to the diagram, that seems reasonable, but it's not drawn to scale, so we can't really trust the diagram, can we? Let's just sub it back in if, to see. Yep, okay. Seems reasonable. Okay, so that's the total length. So this e to the power 5 minus e over 5. Yep. Paddock area to equally be divided in half. Zero to a for ln x plus e minus 1 dx. This must equal a to e to the power 5 minus e over 5. These integrals need to be the same. and then we need to work out what A is. So this is not a difficult question. Integrating ln. Never mind. Have we learnt this? Oh, we haven't. Wait, have we? Let's see. See on the formula sheet. We haven't. Okay. This is a surprise, isn't it? Oh, we could use integration by parts, but this is not specialists. We can't do that. Okay. Um, yeah, wait. We can't. Okay. This is where things get a bit interesting. Hmm. So this is the part where it's a bit complex. Okay. I mean, it's actually not that difficult. We just need to approach it a different way. What is the area? What is the area? Let's work that out. Determine half the area. The area is, like we said, you can use a definite integral. Um, oh wait, we can use graphics calculator. I was about to say, oh, we run into the same problem, but in this case, we have two constants that we can solve in, so it doesn't matter. ln of 5x plus e, and then minus 1. So something like this. And then we go signed area from 0 to e to the 5 minus e, all divided by 5. So this equals 89.591552 squared. That's from the graphics calculator. Okay, we need to do half of that. My apologies. Only half of that area. So what we could do is we could actually just, yeah, we should have done this. So I can write the definite integral equation like so. I'll put the -1. So we get this, which is the exact same value. Now we just put a half in the front of that. Squared GC. Okay. Now we just need to find out how to get the area. There, yeah. Okay. Therefore, 0, this doesn't work because we run into the same issue. Run into the same issue. So I'm not too sure here. Change X, which is a weird solution, a weird idea, but it won't work. I don't know. So we have that. Let's graph that. What does it look like? Actually, we can simplify. Does that simplify or does that just, I don't know, just leave it as it is? Is it? Okay, so basically they're the same thing. I think. Yeah, they seem to be. But in this case, you can actually derive that. I mean, you can actually integrate them. Or you should be able to. I think we cracked the code. Actually, having it expressed as this might be a bit more just when it comes to integrating. Maybe not. I don't know. I don't know at this point in time. Like, yeah, I have no clue. Okay. E to the E of 5 times ED minus E over 5. Okay, now if we integrate this, we have it in terms of D. Right, so the things are reversed. Integral of A to 0, wait, 0 to A of this DD. That is so weird. Oh my goodness, like it doesn't even. Okay. No, I think I understand this. This should work. Theory, this should work. Minus e to the power 5 plus 3e. Go, graph it. Okay, find the root. Only there's two roots, but we ignore the negative solution. Okay. Like this. Root 7, 3, 2. Ignore negative solution. I don't know if this is the correct way. There's probably a much easier way to do this. Now we got in terms of D. So D equals 3.3732943884. Then we sub it in and rearrange for x. So then we have it in terms of x. So the y value is 3.373219438884. Just find the intersection. We get 15. Graphics calculator, x equals 15.360. That should be our answer. If it's not, okay. Term the horizontal. We did do that. What? Nah. What solving application? No way. You can do that? Okay. This. Where? Where? Okay. Okay, so according to a video, it is this. It is, you do use this. You go a definite integral. Let's say it's a ln 5x plus e to the power 1 minus 1. Then you put this all in a bracket as well. And we know that it's in terms of x. And this equals 44.7958. We press OK. That is not what I meant. So this. Okay. Then I think you've got numerical. Then you press solve. There we go. Okay, we do get the answer. So that's how you do it. Okay, so in the future, this is actually very important. This is actually crucial. Questions like these, you will probably not be able to solve quickly or accurately without this. Okay, so that's how you do it. Okay. There you go. So you don't do none of this. Okay, I'm gonna edit that part out so you guys probably won't see the 30 minutes of agonizing boredom, you know. Either way, we lose 2 marks on that, but overall for everything else, to be honest, these 2 marks, yeah, I'll be honest, like, it's just because I didn't know how to do it. If I did, well, easy 2 marks, right? Easy 4 marks. So on the paper, we've done it. So now we've completed the sample methods papers, and in the future I might go over like just a mind map or like the content of chemistry, biology, etc. on the whiteboard. So yeah.